Questions number 11 to 20 on the 2014 Grade 8 AMC 8. Jack wants to bike from his house to Jill's house, which is located 3 blocks east and 2 blocks north of Jack's house. After biking each block, Jack can continue either east or north, but he needs to avoid a dangerous intersection 1 block east and 1 block north of his house. In how many ways can he reach Jill's house by biking a total of 5 blocks? Well, let's talk about this. Let's say this is the approximate grid, and he's got basically a certain restriction at a certain area, and that area is right here, so he can't go there. He's here, and Jill's house is over here. It's 3 blocks going east, and then 2 blocks going north. North, south, west, east. Right? Okay, so, well, let's count. He can go that way. That's 1. He can go that way. That's 2. He can go this way. That's 3. And he can go like this. That's 4. And those are the only valid ones because he can't go through that intersection. So number 11, the answer is A. A magazine printed photos of 3 celebrities along with 3 photos of the celebrities as babies. The baby pictures did not identify the celebrities. Readers were asked to match each celebrity with correct baby pictures. What is the probability that a reader guessing at random will match all 3 correctly as a fraction? Let's say the celebrities are A, B, and C, and their baby pictures are small a, small b, and small c. Well, the possible combinations are as follows. You can either get it right, like this, or you can match them like this, ACB, or BAC, BCA, or CAB, or CBA. These are the 6 possible ways you can match the photos with the celebrities. And the correct one, obviously, is this one. So that's 1 out of the 6. That is the probability that you could get the matching correct if you just were guessing at random. So that is B for number 12. If n and m are integers, n squared plus m squared is even. Which of the following is impossible? Well, let's just give some examples. If n is 3 and m is 5, then that would mean n squared plus m squared is 9 plus 25, and that is 34. And that is indeed even. So both of these are odd, and we got an even result, so I guess D is possible. Which one? Let's see here. This one right here. This is possible, so we can cross that out since that's not impossible. Okay? We can cross out another one. N plus m is even. This one right here, we can cross that out since that's obviously possible with this example. Let's give another example, this time 4 and 6. All right, let's see what's n squared plus m squared this time. It is 16 plus 36. So that is 52. All right, let's talk about this one. 52 is even. So we got an even result as they want. N and m both are even. So this is possible. So therefore cross that out. And n plus m is also even. So this doesn't seem to be possible. And you can do other examples, and you can clearly see that this will not work. So number 13, the answer is D. Rectangle ABC and right triangle DCE have the same area. They are joined to form a trapezoid as shown. What is DE? This is 5, this is 6, like that. So the area of the rectangle is obviously 5 times 6, and that is equal to the area of the triangle, so 1/2 base, which in our case is CE, times height, which is 5. So that means that CE is 12. All right, well, CE is 12. We can easily calculate DE using Pythagoras. 5 squared plus 12 squared. So DE is 25 plus 144, and therefore DE squared is 169, and that means DE is 13. So that would give an answer of B for number 14. The circumference of the circle with center O is divided into 12 equal arcs marked the letters A through L as seen below. What is the number of degrees in the sum of the angles of X and Y? All right, so if you were to join all of these, right, you will clearly see that it will divide it into 12 equal parts. So the full degree all the way around of a circle is 360. So each of those is dividing the 360 by 12. So each of those is 30. So this is 30, this is 30, and so on, right? So this whole thing right here, from here to here, is 4 of those 30s. So that's 120. And this is equal to that because those are both radii. So that's an isosceles triangle. And since it's isosceles, that means this angle and this angle are the same. So that means 120 plus 2x is 180, and therefore 2x is 60, and therefore x is 30. So we got x. All right, same sort of story here. This angle is basically 2 of those 30s, so that is 60. If that is 60 and these two are radii, this is also y. So that means 2y plus 60 is equal to 180. And therefore 2y is equal to 120. And therefore y is equal to 60. So they want you to figure out the sum of x and y. Well, x plus y is obviously 90. So number 15, the answer is C. The middle school 8 basketball conference has 8 teams. Every season, each team plays every other conference team twice, home and away. And each team also plays 4 games against non-conference opponents. What is the total number of games in a season involving the middle school 8 teams? Each of those teams plays the other 7, so that's 56. But this 56 must be divided by 2. Why is that? Because the 56 double counts. AB is the same as BA, right? If Team A is playing B and Team B is playing A, it's the same game. So this 56 is counting these two. So we have to divide by 2 in order to get unique games. But this happens twice, home and away. So we got 28 home games, and then we have another 28 exact same matchups away. Okay, so that 28 and 28 takes care of the teams within the same conference. And then each of those 8 teams plays an additional 4 games against some non-conference opponents. So that's another 32. So now we have to add these guys up. So 56 plus 32 is 88. And that is B for number 16. George walks 1 mile to school. He leaves home at the same time each day, walks at a steady speed of 3 miles per hour, and arrives just as school begins. Today he was distracted by the pleasant weather and walked the first half mile at a speed of only 2 miles per hour. At how many miles per hour must George run the last half mile in order to arrive just as school begins today? Well, we've got a situation where he looks like he is initially going to have a situation as follows. So we use the standard formula, speed is equal to distance over time. So he walks 1 mile and it's at 3 miles per hour. So we have to figure out time. So time is distance over speed, right? So distance is 1 mile and the speed is 3 miles per hour. So the time is basically 1/3 of an hour. And 1/3 of an hour is 20 minutes. Correct? So 20 minutes is how long it takes him to go to school. Now the next day he breaks it up. He walks a half a mile and then does a run for the second half. the first half here, he is walking at only 2 miles per hour. So that's a half a mile. So that d over s basically becomes a half over 2, which is a quarter of an hour, which is basically 15 minutes. So that means this first half was 15 minutes. Now, in order to reach school just as it begins, he's got to cover this next half in 5 minutes, right? Because his total time cannot be more than 20. So, again, we now have to use this piece of information, but we have to convert this 5 minutes to hours. Well, that's no problem. That's 1 over 12 hours. Okay, so now we have to figure out the speed. So let's use that formula. Speed is equal to distance over time. The distance is a half of a mile, right? And the speed, the time is 1 over 12. So the speed is 1 over 12, 1 over 2. Invert and multiply, and you get 12 over 1, and that gives you a speed of 6. And that's the answer. 6 miles per hour for that second half is how fast he has to run. So number 17, the answer is B. 4 children were born at City Hospital yesterday. Assuming each child is equally likely to be a boy or girl, which of the following outcomes is most likely? Well, we have a situation where for each child there's 4 kids, right? So 1, 2, 3, 4. There's 2 possibilities for each, either male or female. So in total we have 2 times 2 times 2 times 2, which is 16 possible outcomes. And the 16 possible outcomes, since there's not that many of them, we can just write them out. The first, of course, is all boys. The second is if you have 1 girl, but that 1 girl can be in a different order, right? That's why I'm writing this out. It could be in the last girl, the third girl, second girl, like that. And then we have another scenario where we have 2 boys or 2 girls. So those give you the following. Either, basically, that's the scenarios for 2 girls and 2 boys. And now we have to do the one scenario where you have only 1 boy, so that's pretty straightforward. Boy, G, but the boy can be here, here, or here. So I just fill all the rest with G's. And then the last scenario, of course, is when you have all girls. Okay, so let's talk about these. All 4 are boys, the first choice. Well, this is all 4 are boys, and there's 1 out of 16 probability of that happening. There's 16 scenarios, if I've written this correctly, and there's only 1 of 16 scenarios will all 4 are boys. All 4 are girls. All 4 are girls is 1 over 16 as well. C, 2 girls and 2 boys. Well, that's these guys. And 6 out of the 16, which is 3 out of 8. And then 3 of one gender and 1 of the other gender, so it's these guys and these guys, so that's 8 over 16, which is a half. So of all of these, the one that's most likely is this one, since that's the biggest number, and that belongs to this category. 3 are one gender and 1 is the other gender. So number 18, the answer is D. A cube with 3-inch edges is to be constructed from 27 smaller cubes with 1-inch edges. 21 of the cubes are colored red, and 6 are colored white. If the 3-inch cubes are constructed to have the smallest possible white surface, what fraction of the surface area is white? Okay, so let's draw a little diagram here. All right, so we want the minimum number of white cubes in the surface area, and there's only 6 of them, right? 6 are white, so we got white, white 6 times. Well, all of those 27 cubes except 1 will contribute to the surface area. The one that doesn't is in the middle, the very middle that obviously you can't see. So let's put that one in the middle. That will minimize the number of white that are in the surface area. The other 5, we have to show them in the surface area somewhere. There's no way of hiding those guys. Well, I can put them here. so that they only contribute one side. So each of those 5 will be placed in those center positions so that they contribute only one side. So that means of the, let's see here, 6 faces, each of them has 9 of those small cubes. That's 54. So the 54, only 5 are going to be white. And the rest are going to be all red. These 5. This one, this one, this one, this one, and this one. If you put them in the middle like that. So 5 over 54 is the answer to number 19, and that is choice A. Rectangle ABCD has sides CD equals 3, DA equals 5. A circle with radius 1 is centered at A. A circle of radius 2 is centered at B. And a circle with radius 3 is centered at C. Which of the following is closest to the area inside the region? Inside the rectangle, but outside the circle. So that region is this right here. This right here. So how do we figure that out? This. Well, that region can be figured out as follows. We've got basically a rectangle, 5 times 3. We'll call it region, R for region. And then we have to subtract 3 quarter circles. So the first quarter circle is going to be pi r squared divided by 4. But r for the first one, I'll just use this guy, this little guy, is 1. Then we have to subtract this quarter circle. And that has a radius of 2. So 2 squared over 4. And then, of course, this quarter circle, that has a radius of 3. So pi 3 squared over 4. So this gives me 15 minus pi over 4 minus 4 pi over 4 minus 9 pi over 4. So this is 15 minus 14 pi over 4. And you can use pi is equal to 3.14 approximately. And when you do that math, you get approximately 4 as your answer. So number 20, the answer is B.